So warm-up / review. Average rate of change, that's just algebra slope. So that would be f of b minus f of a over b minus a. Average rate of change, AROC. How do you find the average value? So average is in there, but average rate of change versus average value. This is the formula that you just have to know. Average value of f, it's the area divided by the width. So 1 over b minus a, that's the width. Integral from a to b, f of x dx. So we're talking big picture today. Like the details are, you plug things in, or you take an integral, or you look at area, or you approximate it with the Riemann sum. Those are different ways to find the value of the integral, but you use that to find average value. How do you find the change in f from x equal a to x equal b? Not the derivative, because that would be the instantaneous change at some spot, but just how much does f change by? This is actually easier than any of the others. It's just
f of b minus f of a.
Yes, exactly, f of b minus f of a. Which, so that's what it asks for. How we might find that is the integral from a to b, the antiderivative, but the antiderivative of what would get me back to f? F prime. So the answer to the question is f of b minus f of a. One way we might find it is the antiderivative. The other way we might find it is if we had f, we would just plug in b and plug in a. Number 4, if f is positive, how do you find the area between f and the x-axis from x equals a to x equals b? So f is positive, there's a to b. We want this area, the antiderivative. So that area, antiderivative from a to b, f of x dx. How do you find the rate that f is changing at x equals a? Rate that f is changing. What's that fancy talk for? That's IROC. That's f prime. And at a means we would plug in a. So this is a good review to, we're constantly going back and forth between like big picture, what do these things tell us, but then also the details of, well, how do I take a derivative? How do I take an antiderivative? And so we've got to have both of those things in mind. Oh, we sort of already answered number 6. The antiderivative of f prime gets us back to f, and if we've got limits, f of b minus f of a. What if we didn't have limits? I add a little line here. The antiderivative of f prime, f of x plus c. So there's no limits to plug in, but we do need to have the plus c on there. Number 7, if h is the height of a tree in feet and t is in years, what is the meaning of the antiderivative of h prime? Well, let's say what this equals to, and then maybe we can get the meaning of it. The antiderivative of the derivative,
it's going to be h.
It's going to be h. H of 7 minus h of 3. So to me, I can interpret h of 7 minus h of 3 a whole lot easier than I can interpret the antiderivative of the derivative. So what does h of 7 minus h of 3 mean? Careful, don't say growth, just say,
Change.
in fact, let's just say change in height. Because growth sounds like a rate, and it's not a rate, it's just the change in height from year 3 to year 7. So it's kind of an easy answer, but it starts out really tricky because the antiderivative of a derivative. Part B, what is the meaning of 1 over 7 minus 3 integral from 3 to 7? That formula should look familiar. What is that equal to? That's the average value of h from 7 to 3. So what does this mean now? So like in the average height of the tree from 3 to 7. Average height of tree from year 3 to 7. What is the meaning of h prime at 5? So what's h prime at 5 mean?
The slope of h at 5 years.
Okay. That's not a good enough answer yet.
Instantaneous change.
The slope of h at year 5. So that's not wrong, but that's not a meaning for this problem. So use some of the words in the problem statement. Rate of change of h, so of the height of the tree, of the height at year 5. So how fast it's growing. So that would be in feet per year if we wanted the units of that. So it's growing at 1 feet per year or 2.5 feet per year or whatever. Number 8, multiple choice question here. Which of the following is the fundamental theorem of calculus? So look at those and see if you can. Actually, why don't you see if you can answer 8, 9, and 10? I think those are pretty straightforward. So try 8, 9, and 10. Number 10 would give you the graph of f and ask all kinds of questions about g. So you have to write g prime equals f, and then g double prime equals f prime, which is the slope of f. And so then you know what you're looking for on the graph. All right, we went through that, I think, fairly quickly, but I hope that was review. I hope you knew most of those. Most of them, anyway. Flip that over. This is my addition to the test-based review. Find the instantaneous rate of change of f prime of x at x equals 2 if f of x equals x to the 4th minus 2x cubed. I'll give you a minute to write that down. Find the instantaneous rate of change of f prime at x equals 2 if f of x equals x to the 4th minus 2x cubed.
So are you asking for the second derivative?
Yes. So that's the trick, is you have to read that really, really carefully. Instantaneous rate of change. What does that mean? Derivative. So this is asking you to find the derivative of f prime. So if you just read that really quickly and not very carefully, your brain thinks, oh, find the derivative, all right, so let's take a derivative. But that's not what it asks. It wants you to find the derivative of f prime. Well, I guess we better find f prime first. Let's pick on some people because this should be quick. So, Belle, what's the derivative of f? cubed minus 6x squared. So now I want the derivative of f prime. Kind of put it in words. Austin, what's the derivative of f prime?
X squared minus 1.
Good. So the question wasn't hard to do, but maybe it was hard to understand because of how it was worded. It's still not finished yet, Peyton. What do I need to do to fully answer this question? Plug in 2. So I guess I want to switch to calling this f double prime. But if you just left it derivative of f prime, that would be fine too. That's exactly what they asked for. 12 times 2 squared minus 12 times 2. Safe stop. Thank you very much. Not that one's very hard. 48 minus 24 is 24. And tomorrow is all multiple choice, so it's going to be reduced, simplified to 24. There's not a ton of questions that are that kind of tricky, but there's definitely, I'm trying to think, I think there were 2. Wait, that was the final that was worded like that. So the test may have 1 or 2 that are, be very careful when you read those questions.
Is there a calculator and non-calculator section?
Tomorrow is,
Non-calculator?
I think, all non-calculator. I'm still recording. Let me go. The height of a tree is given by a strictly increasing. So strictly increasing means it's never decreasing. It could level out at just a spot, but then it's increasing again. So it's never decreasing. Twice differentiable function, so it's got 2 derivatives. H in feet, time in years. Height is recorded at selected times given the table above. Using correct units, explain the meaning of, here we go again with this explain the meaning of, the integral from 0 to 7 times 1/7 h of t in the context of the problem. So this is about recognizing what is that the formula of. Whoops, I need to include the dt there. That's an average value formula. So that's the average value of the height,
Of the percentages.
or I guess we could just say the average height of the tree from 0 to 7 years. Units, so what would the unit be? I mean, you can either do the math here, or you should just be able to say, what's the average height? What's the unit of the average height going to be?
Feet per year.
The average height
Or
is just going to be feet. Feet per year would be a rate, a growth. So its average height is just going to be 10, 12, 14, somewhere in there. Part B, approximate the average height of the tree. You should really be paying attention. If you didn't know A and then you read B, hopefully your brain would think, wait a minute, that's what that is, average height. Approximate the average height of the tree during the first 5 years. Oh, be careful, so we need to stop at 5. Using a left Riemann sum and 4 subintervals. So average height would be 1 over 5 minus 0, integral 0 to 5 of the height. Now, we don't have a function that we could antiderivative, but we have a table that we could approximate with a Riemann sum. So 1/5 out front, and then we'll approximate the integral with the Riemann sum. And we better be careful because the table goes to 7, but we want to stop at 5. So if I'm kind of drawing my rectangles to visualize this here. So the first rectangle, how wide is the first rectangle? 1 or 3.1? 1 wide. And how tall is the first rectangle? 0, because we're using a left Riemann sum. Now that means you could leave that out, but I think I would include it because I'm trying to keep track of my rectangles here. So first rectangle is 1 times 0. Second rectangle, how wide is it? 1. And which height will we use? 3.1. Third rectangle is 2 wide, and we'll use 5.4. And then the fourth rectangle is 1 wide times 12.8. Always using the left-hand side. And that's a definite safe stop right there. Like, I don't want to...
No touchy.
Yeah, don't mess that up. If you had a calculator, you could plug it in and get an answer, but let's leave that alone. Part C, is your approximation in Part B greater or less than the actual average height over the first 5 years? Well, my function is increasing. I don't really know how, like what it looks like, but it's increasing. So if I divide that into 4 rectangles, or 4 subintervals, that's the right word, and I use the left-hand height each time, that's underneath. So my approximation is less than the actual, because, so my reason, what's my reason?
Left or even sum on a strictly increasing?
That's it, because exactly what it looks like, a left sum on an increasing function underestimates. So I just put into words exactly what you saw. Coming from the left on an increasing function is going to underestimate. Part D, approximate h prime of 3. So approximate the IROC.
Can you use AROC here?
Yep, anytime you're approximating IROC, you're probably going to be using AROC.
Isn't that MBT?
So that is related to MVT, definitely. Let's see. So that would be for 3. So AROC is like algebra slope, which means I need 2 points. And they asked for h prime and 3. So
2 and 4.
likely our best guess is 2 and 4. I suppose you could argue that 1 to 4 would approximate it, and 2 to 5 would approximate it as well. But 2 to 4 is probably our best bet there. H of 4 minus h of 2 over 4 minus 2. 12.8 minus 5.4 over 4 minus 2. Okay, so there's the first part. Let's make sure we answer all of this question, though. Using correct units, explain the meaning of h prime of 3 in the context of the problem. Well, I can get units from the formula I used here. H is in feet, time is in years. So my unit is feet per year. That might help me explain what it means. So h prime of 3 is, what does h prime of 3 represent?
The slope.
Yeah, I mean, slope is right, but let's use different, because slope is sort of related to y and x type stuff. So let's say rate of change, that's a good word, is rate of change of height at year 3, or during year 3. And we know we approximated it, but they know we approximated it, and it didn't say something about explain the approximation. It just said explain h prime of 3. So h prime of 3 is the rate of change of the height at year 3, and we've approximated it, because that's the best we could do. Question E. Find the antiderivative of h prime. Well, let's stop there. I think I like this problem. It looks, right, when it gets too complicated, actually the complications cancel each other out. Because what's the antiderivative of h prime? H. And then we have limits, so h of 5 minus h of 2. So, in some sense, E is the easiest calculation because all I'm doing is 14.5 minus 5.4. And in units, that's feet. So we found it. Explain the meaning of it. That's the best.
Change in h to t from 2 to 5.
The change in h from 2 to 5. Maybe 2 to 5 years to be clear.
Or you could put x equals 2 to x equals 5. Or t equals 2.
Yeah.
If you wanted to.
I think you could say that because it already said t is in years, so. Yeah. Part F. For 7 to 10, 7 to 10, I look at my table like there is no, don't got no, but they're about to give me, for 7 to 10, they gave me this for the rate is given by dg dt. Right, but don't evaluate. That's a fairly frequent thing on AP test. Right, but don't evaluate. Because usually when they say that, what you write ends up really complicated. And they're like, all right, if you could write it, that's what we're going for.
And you don't want to.
We don't want to mess with that. Right, but don't evaluate. An expression containing an integral, so there's your hint that it's going to be complicated, which gives the height of the tree at t equals 9 years. Okay. So I know how it grows from 7 to 9. So let's integrate dg dt with respect to t from 7 to 9. And that would give me, well, I don't know whether to use g or h, but I guess I should use g.
Can you also do 9 to 10? Because of the interval it gave us?
Well, if I did 9 to 10, here's the reason I'm doing 7 to 9 rather than 9 to 10. Anybody know why I'm doing 7 to 9 rather than 9 to 10? We have 7. I know what g of 7 is. I know how tall the tree is. I haven't solved for g of 9 yet, but I'm almost there. So it's g of 7, which I guess I should plug in, 19.3, plus the integral from 7 to 9. And then I could write all of this out, or I could just write dg dt, because it says write but don't evaluate, so I can do either one. If dg dt times dt looks funny, and that's bothering you,
You can change it.
it's kind of bothering me, although it's still correct. And maybe you write it like that and feel better about things.
I just notated that dg dt is g prime.
Yes, you could do that. As long as you say that g prime equals that, then you could put g prime in there. Definitely. Did we answer everything? If there wasn't any explain or whatever. Okay, so this is why it's right but don't evaluate, because maybe we don't even have a calculator. Which I guess we could still do that without a calculator, but
Yeah, do you want to?
no. Like at this point in the problem, like if you can write that, we're good.
A is the next one.
Intervallus. That's the Latin for interval, maybe. Number 2. Let f be a continuous function defined on the closed interval -4 to 6. And we've got a graph from -4 to 6. The graph of f, consisting of 4 line segments, is shown on the right. Let g be defined as the integral from 0 to x of f of x. On what open intervaluses on 4 to 6 is the graph of g concave up? Give a reason for your answer. Well, let's give our reason first, because then we'll know what we're looking for. G G is concave up, let me get you involved here, Nick. When is G concave up?
Double derivative of the graph of f is positive.
Answer it. So I like where you're headed because we will need to use the graph of f. But answer it just in terms of G. Like you don't know anything else. When is G concave up?
When G double prime is positive.
There you go. When G double prime is positive. Now you were on the right track. We don't know anything about G double prime. We know G in terms of f. So we need to figure out what G double prime is.
F prime.
So let's go one step at a time here. What's G prime equal to?
F of t.
F. And that means G double prime is F prime. And then that's all I need to say, but maybe it's helpful. What is F prime? Especially if I'm looking at the graph of F, the slope. So I wouldn't have to say this, but this is definitely what my brain is thinking, the slope of F. So G double prime is the slope of F. Now, I don't need to put that as part of my explanation because I already have said that G double prime is the slope of F. But, again, if it helps me think through what's going on. So I'm looking for where the slope of F is positive. So, Logan, can you look at that picture and give me some intervals where the slope of F is positive?
Would it be from -4 to -2?
I like that.
Maybe from 2 to 6.
Yes. So,
More?
nope, that's it, right? Everywhere else, the slope is negative. It's like, that's good. On what intervals is the graph of G decreasing? Justify your answer. Justify first, I think. G is decreasing. Luna, when is G decreasing?
When G is decreasing.
Don't look at anything else. Just answer in
When
terms of G.
F prime is negative.
Let's answer in terms of G first.
When
Right,
G prime is negative.
yes, when G prime is negative. So I think it's helpful to answer the question in terms of how it's asked first, and then try to translate it into F. So you're right. We do need to know what it means in terms of F. G is decreasing when G prime is negative, but G prime is equal to F. So Callista, I'm looking at the graph, and I want to know where F is negative. I want to know where the graph of F is negative. 1 to 6.
Numbers.
At what value does the graph of G have a critical number? State whether it's max or min or neither. Justify your answer. G has a critical number when move all the popsicle sticks back over. Isaiah, what's a critical number?
Is that 1?
Not when. I most want like in general, like the definition of a critical number
When
is.
it switches from positive to negative.
I mean, that's where we'll look eventually. But what would you say about G prime? G has a critical number. Like, independent of this problem, we should be able to answer this question. G has a critical number when G prime is. There's two things. So we've got to answer this first before we start looking at things.
0. When it's 0 and G double prime is changing sign.
Just 0 or undefined.
Oh,
So answer it in terms of G, and then now we'll translate to F. So G prime is F. So all I care about is when F is 0 or undefined. So that's at x equals. So Mia, where is F 0 or undefined? Mm-hmm.
-2, 0.
Wait, I don't think f is undefined at -2. F prime is undefined at -2. Right? But f at -2 is 6. There is a value there.
And so would it just be -0.6?
There's one other spot where f is 0. At 1. I'm just looking for where the graph crosses 0. So not derivatives, just the graph itself. F is 0 at -4, at 1, and at 6. Min, max, neither. Let's start with 1, because I think that's the easiest one, and we're almost out of time. So at x equals 1, what's g prime doing? Or what's f doing?
It's changing from negative to positive.
And so what does that mean? Wait, it changes from positive to negative.
Oh, at 6.
At 1,
Oh, we're at 1?
g changes from
Positive to negative.
positive to negative,
So it's a max.
so that's a max. A relative max.
But still.
At -4 and at 6,
Min?
it doesn't change. We don't know that it changes, so I think I have to say neither. Right? To be a max, it has to be the top of a hill, and I don't know that it's the top of a hill.
And
Or the bottom of a
endpoints
hill.
Don't get to be
Right? Endpoints
critical
can't.
numbers, but they don't get to be mins or max.
They can't be a relative min or max. They might be the overall min or max.
Yeah.
All right, so I think we've got a lot of good review in there. Plus worksheet 4 answers are posted if you want more help. Tomorrow, Tuesday, I have duty part B, so I'll do tutoring part A tomorrow.
Blocking?
Yes. Don't tell pre-cal.
What's happening?